Yeah, I'm glad you took the time to do that, actually. I mean, you of all people would know if they're ready, right? So that's cool.
I hope so. I hope they're ready. So
Right, definitely. Like even after I did it earlier, a few of them were still wavering about like, oh, maybe we should change this and so on. So I still encountered a couple of teams kind of not very focused on what they wanted to do. I wasn't very happy about that, but anyway. Okay, so we're going to, you need to leave?
Yeah, I can ask my question really
Go ahead.
quickly.
Okay.
Okay, I have a quick question for everyone. This is Catherine. And that's, are any of you using iClickers in your EPICS classes?
no, I don't.
No? Okay, that's okay. I'm really just wondering.
Would it be useful at all? What about in Boulder, Lena?
I
Did you
think
use it in Boulder?
I think I can say yes and no. So they are useful because you ask a question and then it's recorded immediately, and it sends as a grade, right? But also there is you have to do a lot of coordination, a lot of, I don't know. So I have mixed feelings about it. I think sometimes they can be good and useful. Sometimes they can be a burden.
Yeah, that makes sense. So would anyone be interested in iClicker training? And it's totally fine if that's not something you're interested right now.
Maybe not now, but I would imagine, you know what I mean? Like senior design uses iClicker to actually literally keep track on absences.
Mm-hmm.
So they kind of like spot a question and say, what's your answer and whatever, but that's how they do it. But what about you, Robin?
I used it for a class up in Alaska.
Mm-hmm.
It seemed to be good for getting an understanding about where particularly a lot of the quiet ones are at in their understanding of certain concepts.
Mm-hmm.
The classes were small enough that it wasn't such a big issue from an attendance perspective.
Yeah.
So it does give that understanding.
Okay, so maybe we'll postpone that and have that in mind for the future.
That's what I think. It could be part of our kickoff.
Yeah, that's a possibility. All right. Thank you.
Thank you. Is this recording then?
Yeah, it should be.
Awesome. Okay, so I think Robin sent you.
Yeah, I didn't have Danny's email.
Okay, Alina, you should
Yes.
have an email from Robin. And
Yeah, I just got it and I looked over the document with the testing specifications for shoreline and for water.
Yeah. And Danny, bear with us.
I got that.
We'll go ahead and send it over to you, okay? Very soon. All right. So first line of business. Did you get any questions like that from your students?
The only thing I got was where they said they had a lot of different components, and do they have to actually have everything totally functional? And I told them that they had to pick out the critical elements that needed to be functional, but they needed to still have a looks like component of that additional functionality associated with it looks like.
By the end of the semester.
By the end of the semester, yeah.
That's a really good answer.
Most definitely, yeah. So hopefully everybody heard what Robin said, but basically the idea is to list the critical features and then be able to then test those and obviously build it, right? And then test it. But before building the prototype, obviously, then our procedure says for us to actually design the tests. I guess that's kind of like where this comes in handy. So we talked a little bit about why we're doing worksite prototype. And hold on one second. Bear with me. Right. What are we doing? Oh, I
I'm
see.
just trying to make it so Rob and I can see too, but I was failing miserably until I just realized that Catherine already had it.
Yeah, she does. Yeah, it's shared with everyone. Right. So, why do we prototype? Okay. Now here we're talking about more of validating your concept against some type of baseline. And so I added these pictures just for fun, but naturally what I meant here was that, you know, there's all sorts of things that they are doing that is more specific to their individual solution. They may or may not need to test all of this. And there are certain things that are very basic that we will propose as test beds. So anyway, this is just kind of like a simple prime for them to get their heads wrapped around, you know, what exactly needs to be tested, right? And they have to seek for whatever, because when we did this before, we had some type of parameters, like defined parameters. In this case, this is where Robin's document comes really handy. Robin, would you like to speak to that?
So I just, I did it more from the perspective of how big or small can something be to actually then be tested, associated with the functionality, and still be in kind of a safe status. And so on the water side, and these are really just food for thought, and certainly for people's input, but that it should have a, if you're thinking in a horizontal plane for a water collection, that it would be somewhere between 18 inches and 36 inches. Because if you have an 8-foot diameter kiddie pool, you can still maneuver in it, and it should probably be at least 18 inches so you can actually collect something. And then no deeper than an 18-inch below water surface, just because, one, we don't want to have a large volume of water sitting inside a pool, but then also that predominantly things float. And so they can be able to test that. They can still test a solution that is still within that range. The other things that I mentioned was that all of their electronics need to be water sealed. It cannot just be water resistant, because what we don't want to have is an electrical system inside a water column that is live. And then I also talk about that they should specify what kind of, I call it a D50, but that's just your 50% range, your midpoint. What are you actually targeting as far as the size? And then what is the range of that you're looking at? So if you're targeting just microbeads, then say that. If you're targeting fishing nets, say that. And then on the shoreline, a similar approach that it's between 18 to 36 inches in any direction on the horizontal plane. That they have to specify a D50, and then they should specify in what kind of soil substrate they're actually going to be collecting the material. So it's not a lot of constraints, but it does at least start to bound what we have to provide or think about as they're doing the prototype testing.
Thank you. Thank you.
Excellent.
This is wonderful.
Yeah.
Is there something we can do with this slide that would help tee this up a little bit better? Like, and what we were trying to do is kind of go, you know, what is a way to talk about, actually, I guess they're related but different conversations. Is there something here that we can do to lead into this conversation a little more smoothly?
Well, and their baselines have to also be against what is currently being done out there.
Right.
Because the kind of part that they have to be able to show that they're actually improving
Something.
And that's a good philosophical question. For shoreline collection, we kind of have a sense of what the baseline is. But in water collection, you know, there's these one-off solution and concepts out there, but I don't think, like, if there's nothing really being done
for certain things.
Like for the garbage patch, for instance.
Yeah, then they have to say that it's more of a condition of, now I am going to go out and collect this, and I'm targeting my efficiency and effectiveness is X. and I'm actually going to collect this, but my potential impact from my carbon footprint and cost is this. Does this outweigh this?
The
Right,
cost and the benefit analyses.
Yeah.
Which is
So,
a different way of looking at it.
Maybe that's it. For those of them that actually like say, like the Mr. Wheel, some of them are kind of replicating that Mr. Wheel in the Boston Harbor.
Oh, the Boston Harbor, the waterway.
Yeah, and trying to make improvements on that. Maybe for them, those of them that actually are having those existing solutions that are out there, that's going to be their baseline if they can find what that is. But
Yeah, they should be able to find out information on that.
for ones that are still in prototype stage out in the deep sea, like the one with the V, I can't remember his name.
Kid?
The kid.
I remember his name.
Ocean cleanup, yeah. So for those, then that's what you were saying, right? Cost benefit analyses,
And that almost applies to everybody, no matter what they're doing.
no matter what they're doing.
Yeah, and the same on shoreline. I mean,
Yes.
the biggest is, they're comparing it against volunteer labor.
Yeah.
But that's still labor that could otherwise be doing something
Something
else.
That's true.
What percentage of your teams that you've seen, all of you are doing adaptations of stuff that already exists? Like put a bucket in the water and let the top skim into the bucket and filter it out. Use that approach from the sea bin, I think there's a slide for that.
But they need to do something different. Like they need to take
Totally
that to the
different.
next
I
step.
told them they have to adapt it, and just make sure it's well distinguished and somehow different. So
Yeah, like one of my teams proposed that, and then they had an actual vacuum mechanism that went to a house on shore and then pumped the seawater out. So it was actually like a vacuum cleaner
That's
system.
good. That's
I
good.
was like, that's a good adaptation of that.
Exactly.
So that's, yeah.
I had teams talking about not leaving it tethered to the pier and finding a way to be able to move it around.
Yes.
For example, things like that. So I was wondering what level or what extremity of adaptation, how far are you having them depart from those existing ideas that are already out there? So that gives
That's
me
a
an
hard
idea.
question to answer.
Yeah.
But yes, they should be departing from it, but it's about how do you articulate how
Right.
much? It's really hard to get across.
Okay.
Well, even having it mobilized is a big deal.
Yeah.
So then what do you do, right? And so
How do you keep it? How do you keep it upright?
Yeah.
And
Well,
partially submerged. So the lip is
yeah.
submerged. How do you do that?
Yeah.
So
They're
that one
struggling
team
with
that's
that.
doing kind of a dual net where they have one group doing an anchoring system, but then they also have, at least what they're talking about is then being able to make it mobile, that once it's at a certain collection period, that it will reestablish itself.
Reestablish itself. Cool.
The most unique idea I've seen so far is a sluice. So it works the same way as a gold sluice, except instead of sifting for the stuff at the bottom, you're sifting for the stuff at the top.
Oh.
Plastic. So I'd like to see that in action.
No. Anyway,
Oh, sorry.
no, not at all. Robin, can you and I talk more about like how to manipulate this one slide better and then lead into this conversation better and maybe things to add? Okay, awesome.
Thank you.
Yeah, and then
And if anybody's got some changes or if this is too constraining or not constraining enough, it's just trying to kind of put some balance.
I
right,
really like it.
I really do.
I knew we needed this. I didn't even know how to articulate that we needed this. And then you just did it. So thank you.
She just has all this experience with kiddie pools.
Yeah, that's always good.
Who would have think, right? Anyway, revisit worksite prototype. Why is that important? All right, I'm not.
We may have lost some folks. You lost us.
Oh
You lost
no!
Catherine.
How'd you lost you?
Can you see if
Is anybody still there?
Well, Danny's still here, and I think Catherine's there.
I'm still here, yeah.
Yeah, Kim is still there. Did it just shut down?
Anyway.
Oh, well, good thing you're hosting.
Bingo.
All right, and as long as it's recording, that's all, because the other day I failed to record. Okay, guys, the one thing that we changed from last semester, I just wanted to point out here. Where is that? Oh, excuse me. Excuse my French. Oh, I know what it was. So we talked about works like prototype and what that would be looking like. Do you have it? Do you guys have it?
No.
Okay.
Yeah, I'll try my laptop again.
So if a worksite prototype is a partial residential solution, what part might that be? So in the beginning, they might have a little bit of struggle about what Robin was saying. How to optimize that $100 and actually allocate it to like the critical feature that they actually have to test, right?
Yeah.
One thing that I might mention is that one says what details can be left out, and maybe we can say what details would be in a
Looks like prototype.
versus that
Perfect.
just disregard it.
Yes.
Good.
All right.
Good.
Thank goodness.
Can't connect. Oops, not bad.
Okay.
Can you see hers okay, Yosef?
Yeah.
All right. And so,
Tell me when you're flipping slides.
all right. Next slide is slide 10. Slide 10. And then we talk about what shouldn't be prototype. And this is pretty much sparked from a conversation with Robin Steele, I believe. Just thinking about, some of them have wow features, if you will, ones that have to use biofilters and all these very, not outlandish, but maybe the fact that it's just like the resources are not here, or it just, we are not able to actually replicate in a way that would be useful for them to test anything. So we're just giving an example of, exactly what would not be appropriate to prototype.
Is this helpful? I mean, I guess these are teaching notes. Do with them what you'd like to, including fixing the typo in the last sentence. Sorry about that.
Wait, what typo?
And use subsystems analysis.
Ooh, my bad.
Mine. I get that one.
Okay, well, here we go. So and then we go into team time and talk about, the most important functional aspects, etc. And I will stop there to see if anybody has comments, questions.
And maybe it's less what details can be left out and more what details are looks like prototyped only.
That's
Right,
what
'cause
Robin
you would still want to include that in what your
Excuse me. Thank you.
full scale approach would look like for the
Right.
final design. So you can't leave out the policy.
Are you on version 3 to make those changes, Myrna?
I will do that.
Awesome. Thank you.
Okay.
I'll make sure. I do.
So anyway, I will take a little bit of our time, if I may, and ask, because my understanding for now is subsystems, what they are asked to do is to write a report on the idealized model, right? And so that's how it's broken down and actually.
I thought it was on the prototype.
No.
So
See,
there's a misalignment.
so there's a misalignment because
there might be a way
last
around
semester,
it.
exactly. So last semester, I think Robin, you and I went like that, right? From bottom, whatever, top, bottom, whatever you want to call it. It's the other way around where we are actually asking them to make a subsystems report on how to build a prototype.
Or how
or
to
from-
design. So here's the problem. The problem is that not all of the subsystems need to be works like prototyped. By the end of the semester, it all needs to be prototyped. But if the subsystem analysis includes too much information about how their subsystem tested out and how they iterated, then some are going to be much more interesting that way than the other ones. And how do we do that? How do we get around that disconnect? Or what would you do?
You mean like a subsystem that's a battery versus a subsystem that is a command
Filter.
structure?
Yeah,
or something?
Yeah, exactly. Like somebody wants to try a baleen whale structure to filter out microbeads. It's like, okay, go figure that out. That's awesome. Whereas somebody else's subsystem is how is this thing going to be anchored into a river bottom or whatever? And that's it might not need to be tested because it's just structural element.
Yeah, you probably still upload what you can test on. But and I've got some of those in the past, and I just look to whether or not they actually fulfill, did they describe out what their subsystem actually does. Whether it's as interesting as the other part, they're still all critical elements.
Yeah, that's true. Okay, and I think it's the question of like when we say which functional aspects need to be, like how do you decide what to prototype? It's what are the most important functional aspects and what are their assumptions that need to be tested, what parts do you need to figure out better, all that kind of stuff. And some subsystems are just more obvious, like don't prototype vehicle wheels. Like if it's the exterior housing, I mean, that's a looks like prototype rather than a works like prototype. So were you suggesting, Robin, that in week 11, some teams are doing works like, some individuals are doing works like, and some individuals are doing looks like?
I guess I hadn't anticipated that there would be any system that somebody didn't have a works like component. Last semester there was some people that had more of the simplistic, like keen, polls. So one of them took the actual risk to the people by being so close, but they did calculations on explosion distance, they did calculation on deformation of body organs, and so there was still a subsystem report that was tangible enough to actually say this is my proof of concept associated with why this design criteria is acceptable. So there were still calculations and all that.
Yeah, okay, that makes sense.
So it wasn't actually working, but it was important.
Analyzed thoroughly.
I think what convinced me to go your bottom-up approach instead of top to bottom was exactly that, the proof of concept.
Yeah.
And so
that I've described it to people is if I'm going to go and approach somebody for money, I'm going to first approach them for something on a small widget size and say, can I actually make this whole thing functional? And then I'll put the tone on the full scale and say, don't just trust me, trust that I've done all this testing and the works like to be able to prove your full scale. Yeah. So you have to have some proof
that it's going to work. Okay.
But
Go ahead.
I'm sorry. I just wanted to kind of like direct the conversation to people that are feeling strongly the other way around, like top to bottom. So
I don't feel strongly one way or the other. I just I have a question. So what if they have a vehicle attachment and they're going to spend their $100 on this accessory that attaches to some boat or vehicle that's on shore? For example, I have folks that are working on some sort of a device that gets dragged along the shore to pick up. It's a mechanical solution to pick up debris. So they're not expected to prototype a car, right? Because they're going to spend their $100 on building that. But some of the subsystems are going to be things that they can't necessarily test, like maybe the thing has to be hitched to an SUV or something like that. And so they're not going to be testing that. Or maybe it has to be, or maybe it has to mount to the front brake of the car somehow, like kind of like a brush guard would.
Sure.
That was another one that I had. So.
Oh, because this is going to be on shoreline. Okay.
Yeah, for the two of the shoreline teams I'm thinking of.
Yeah. But
so there's going to be a limit to what they can prototype. So
but for that, it's not so much the attachment because we know how to attach things to cars. It's more about what is it actually doing, that interface between the soil and the thing that all needs to be prototyped out, I would think.
So when they're testing it, they would just have human power motivating the scaled down prototype to make it work.
Yeah.
So that's a scenario where teammates who worked on various subsystems would then refocus onto fewer subsystems.
The only thing that I did was
to do the prototyping, I mean.
Where I had some very simplistic, where I could only conceptualize 3 subsystems. I told them that they needed to take it to the next stage of, now how would you do your connections into the processing? How would you actually collect this stuff? How would you print it off?
That's exactly
do something other than watch everybody else work.
Okay. So we can introduce the process side early for teams that have fewer than 5 subsystems or fewer than 5 significant subsystems.
Yeah, or I had some of them just say, I'm going to switch because I can't find 5.
Yeah.
And so they switched to a different thing.
Okay.
But so I don't know. That's up to everybody.
It's good. No, it's good to talk about.
So since we actually have those 2 directions, I know for sure I talked to somebody last semester, and she for sure did like the top to bottom approach.
And I don't understand the 2. What were the 2?
Okay, so the question again, then a student would come and say, so Myrna, is this material that you're asking for the, kind of like the subsystem, is this something that is for the final model? So when they actually go and do a breakdown on their final model, let's say, this is the actual material that's going to be used versus what's used in a prototype.
So what exactly do you analyze in the subsystem?
Oh, I see.
Maybe
Like I always thought it was.
Do you understand what I mean?
Steps
Okay.
towards the, like, I thought, okay, at the end of the day, they had to come up with a works like prototype for the final competition and all the
Right.
classroom competitions. And then our subsystem prototype was a way to make sure they were getting there and then make sure they were testing the various pieces to get there.
right.
So I never looked at it as a separate assignment. But how you get there, you might say, well, this first time I'm going to use window screen, but I know I need to use this other kind of filter later on, but I'm going to see what happens with window screen. That's fine, but as long as it's moving towards the final product, no? Or
Well, then you have two different cost analyses.
Stages, yeah.
And you know what I mean? Like,
so
So is the subsystems report a report of getting to the works like prototype, or is it a report of what the
exactly.
final design subsystems will look like that would be
Yeah.
done
And
in
so-
SolidWorks?
what's the difference?
Well, if you're doing the subsystem, you're going to be saying, okay, I'm building this this feature. It's out of wood. I've done this kind of testing on it. I've got this kind of efficiency around it. So you can say this is what this subsystem looks like
Independently.
as it's an independent function, and here's my interfaces associated with the other subsystems. And then it's a question of whether or not in that report or in the final report do you say, okay, now what are my considerations for full scale as it relates to this subsystem, or do you wait for the whole works like prototype to say what are my considerations then for full scale? Because
Yeah.
now it's that it's going to be built out of titanium,
Right, with solar
Yes.
panels,
with solar panels. and
hydrogen
Yes.
fuel cells.
this cost
Exactly.
is $100, or my subsystem is $2.50. But for full scale, that subsystem will be $7,000.
But they're not even going to do that in their final works like prototype. So there's always a disconnect between the prototype cost and the final design cost.
Yeah, I had them in the final put together. What are your full scale considerations and what might be a full scale cost?
Yeah.
Yeah.
That
And in
was
some
the
classes, they were like, this is the prototype cost is 100, but the solution could be $100,000. And some classes were like, the solution has to be 100. And this time we've explicitly said, we don't care how much the final solution costs as long as there's a value commensurate, and then, but your prototype needs to be 100. And so towards that, okay. And so I think it's a subtle difference of whether or not, how separate are they going? Like right now, here's the team, they've had a couple team deliverables, and now they're going 5 different ways, and then they have to come together at the end for a team deliverable at the end of the day. And the question really is, how separate are we allowing them to go? Yeah, acknowledging that there's interfaces between the pieces. Is that kind of the question?
No, and then here's your full scale up here.
Yeah.
It's that, do they write this for this? Or do they write this for this?
Are they
Oh,
writing
no,
it
it's
for
always been for
disposable
that.
alkaline
Like
batteries?
These are
subsystems?
for that.
Well,
Yeah.
yeah, but are they essentially not talking about their subsystem, but they're talking about this subsystem in their subsystem report?
They should be talking about the whole point of the subsystem was to as a stepping stone towards the final report. And it's okay to concentrate on this level of it as it informed, well, we thought we would do it this way, but that didn't work through our testing, so we did it this way for the final one. But
Well, when I say final, I mean this is the $100,000 item.
oh, I thought you meant the final report
No,
and it
this
looks
is
like.
The
that's
final
the final
design, she
works like.
means.
Right.
The
So
production
it's
design.
that, are they writing the subsystem?
Now I understand.
So this is
Okay.
so this is your idealized model, and then the way that we've done it before.
But what do you mean by
These are
idealized model? That's the $100,000.
The production.
That's the 100. Okay, production model. Okay. All right, and so instead,
Thank you. Sorry for
this is all your
This is fun
subsystems.
conversation.
And then you break it down to what would that look like in the works like prototype, in the material that would be suitable, right? Some still are going to be looking as like what you were saying,
Okay.
right?
But it's
and so
we're all on the same page in that these subsystems are part of this
Works like.
$100
Yeah.
thing.
Right. Well, I think the question is.
But the details, the nitty gritty, might be different for works like versus final production.
Yes,
Right.
Like
So the
what is
question is,
titanium
does
and
the
all that.
subsystem report involve this, or is it this?
Yeah.
is it
And
this or
what
is
did
it
you do?
this?
I did this.
And
I
what you
did this because she convinced me about proof
But a
of
lot of
concept.
people did this.
But a lot of people did
I
this.
did what you guys did. I worked towards the, now that I think about it, I had
You
them
go
work
up.
towards a prototype. And
Yeah.
they had calculations regarding batteries instead of, say, solar panels.
Right,
Stuff like
because we
that.
wanted them to say, what did you learn from this to get to this?
Yes.
Which is the primary reason to do the subsystem.
Yes.
So you're
That's what I
iterating
did.
to get to here. but there were a lot of professors that had them right on this.
Okay. People on the phone, are you guys paying, are you following this
You know what I
conversation?
mean by this?
Okay, I can put this on the camera if that's going to help anybody.
Okay,
These
so,
are using
and so
way too
the
many
question is,
pronouns.
in the subsystems analysis, are they planning towards the final $100,000 solution, or are they planning towards their $100 working prototype?
Exactly.
But what if we said, hey, it's okay if 90% of the focus is at the end of the semester, but 10% of it would be at scale, what do you think your thing would be like?
Yeah, is that, and I had them do that for the final report.
Yes.
I didn't have them do it for the subsystem,
Okay,
because they
that's
were
fine.
still changing things.
Yeah,
Yeah,
wasn't working.
and that too.
it's the same situation for me
Okay,
too.
good.
Because they had, they needed time to.
And that too.
And all three of you did that way. It felt like it worked out okay?
I mean, the challenge was then actually pushing them to talk about the production,
Yeah.
the finals.
Because we get to process maybe after that. anyway,
Yes.
So.
That was the big.
Okay. No, thank you.
And that's where that's why we were talking about how important it is for them to have their visual representations of the final design, because we've never seen it before or heard them
Right.
talk about it
Right.
exactly. So
Right.
that's why the
The engineering
PowerPoint, but the engineering drawings, PowerPoint, the SolidWorks and the engineering drawings are so important, because otherwise we have no visual representation of what their production model will look like. So
But
So do we expect to see prototypes by everybody again in week 11? Yeah, like it should be either a works like or a looks like.
Yeah, hopefully towards it works, but knowing that they have to get their interfaces together. to
And it
actually-
can be rather simple in week 11. It's not graded. It's just a stepwise thing to get you towards the thing.
Mhm. Yeah.
Okay.
As
Or
in,
mood
does stuff
analysis.
work without interfaces? Like if you hit a button, does that thing actuate the way you want it to actuate, even though the thing that would normally trigger the button isn't connected yet?
so I think this is worth kind of making sure everybody's on the same page. And
Because it was different last semester. I mean, people did it differently.
people did it differently. Let's just make sure that everybody's on the same page. So how about we just write maybe with the diagram more or less, and then I'll pass it around with a couple of people and see if at least, somebody outside this meeting right now understands. And instead of talking about this and that,
You
gosh,
can go back to French.
this and that. You guys must be really frustrated right now. It's like, what
I
the
have no
hell?
idea what are they pointing to stuff? I don't know what they're pointing at.
Okay, guys. I don't know what's left of these slides. Let's
We had a
see.
little bit of teamwork stuff, I think.
Oh, that's right.
And then, the design of experiment, I don't think we changed.
No, not at all.
And then, we added a team time about developing a test plan. So before in slide 13, we just said, come up with 5 to 10 steps. And then we added what might those 5 to 10 steps be.
Right.
And then is the first day or the second day when we give them back their computer stuff? Because we'll get it by Friday, right?
Mhm.
But not until Friday night.
Mhm.
So when do they get it back?
Yeah, I'm probably not gonna do that until after spring break. Good
Okay.
point. Because I'm not sure I'm gonna be able to get them to do it on Friday. I was gonna have them do it by Tuesday. I didn't get I've only gotten 2 of my teams.
Okay. So,
Is that okay? To kind of keep that, some people have it due on Friday if you can.
I'm doing the rest of them tomorrow. I talked to 3 or 4 teams per section out of 5. So
Okay.
I have 1 or 2 to do in each section tomorrow.
I've talked to them all, I just don't have their results,
Oh, yeah.
And so maybe what we could do for this Tuesday is put a time hold for professors that want to kind of sit with each team and kind of talk about the thing.
mhm.
And then otherwise, let's put the time hold on the next
After
project day 1.
Project day 1.
Okay, cool. Alrighty.
Okay. You're going to have to repeat what that was because I was trying to figure out the energy management matrix here, but
Okay.
I'll go ahead
We'll
and
talk after this.
yeah, we'll talk a little bit after. We're close to being done. I just wanted to go over the energy management matrix. It's at slide 22, where Robin Steele actually brought up a really good point about exactly what state should they be. Obviously from the looks of it, they should be in the performance zone. But then, if you have low physical energy and negative emotional energy, obviously you'll be exhausted, defeated, hopeless, sad, used up. And those are all true. And, I think it's a good time in, during their team development, if you will, to actually interject this to make sure that then they can actually recover and get to a performance zone. And so they are teaching notes here. I just don't remember what all they are. Let's see, a little help.
Sure. What slide are you on? 24?
24 right now.
Okay. And so I think it's a little team time to talk about, once you walk through what these things mean, where do they spend a lot of their time?
Yep.
In minds, for ethics, and all that kind of stuff. And then there's tips on how do you, in 25, it's how do you get in the upper right quadrant. If you're burned out, reassess your vision and purpose. The touch screen. If you're in survival mode, reassess your activities and all that. If you're in performance, great. And if you're in recovery mode, great for the spring break. So yeah.
There you go. Yeah.
So it was just sort of like, just be aware of what it feels like to be at least drives that, and then what can you do?
What can you do
to reinvigorate to go into no kidding.
They're slammed.
This
They
shall
are
pass.
slammed.
Yeah. Okay, and that was it.
Today is hell day for a lot of people. I'm supposed to.
This week and next week.
Yeah, and
Oh.
next week.
They must
is that
love it.
right?
They must love us today. Then we're covering dimensioning and grading sketchbooks. So they're really pleased with us as
I
well.
learned from the registrar today that what credit hour means, and in terms of in class and outside of class. But the rule of thumb is 1 credit hour means up to 2 hours of homework.
Really?
Not even close.
Yeah, isn't that crazy? Because the amount of work we're spinning off is probably 5 hours a week between the graphics and the project side. And I'm thinking that's way too high. But that's the rule of thumb. It would be 6 hours. I mean, they don't have that time.
Mm-mm. No, and based on what I've heard them say, as far as the time that they put in, it's way over those levels.
For their other classes or for us?
Definitely for their other classes, but still also, because a lot of the feedback I got was there's a lot more work than I thought it was going to be.
Well, whenever they do groan about that, I ask them, they know that rule too. I ask them, well, how much work should you be getting? Since we meet 5 hours a week,
Mm-hmm.
like 10 hours, I'm like, have you ever had to do
But
10
it's
hours of
3
work?
credit
for us?
No, it's 3 credit hours.
It's
It needs to
3
be
credit
6.
hours.
Okay. Well, it's
6
well under
hours
6 too, I think. But yeah.
I don't know. I think we sometimes go over that with prototyping.
Depending
With
on the week.
spikes, we definitely have spikes.
Yeah.
But if you average it
Depending on
out,
the
we're
week.
definitely under 6 hours.
Is that concluding with graphics?
I think so.
I don't like 6 hours a week. That just sounds.
It's a lot though.
It sounds awful, and they're taking 4 or 5 classes.
Only 24 hours. Okay.
Yeah.
My kid barely sleeps. Anyway, that's another conversation, folks. Does anybody have any comments or questions? Otherwise, I think we should be done.
I have a question. This is Greg.
Okay, Greg.
Are the subsystems guidelines and rubrics available somewhere that I'm not finding?
No, not yet. We need to update them for this semester.
Okay. So, and just on the due date on those, we're talking about week 11.
Yeah, if you look at the calendar, it's
I think it's week 12.
It's week 12. There's
Week
nothing,
12.
There's
Okay.
nothing between weeks 8 and 12
Yeah.
if you look on the calendar.
I
Should
mean,
be
other
week
than
Got it.
project room prototype testing and stuff.
Yes,
Oh.
project one.
Yeah.
I'm sorry, Greg. Back to you. It's week 12.
No, yeah. 2 is like week 12.
Did you follow our conversation about, that whole top to bottom up approach? Did that make sense to you, or did I lose you?
Yeah, I think I got most of it. I
Okay,
couldn't
good.
repeat it back to you right now, but yeah, I think it'll
That's
make more
fine.
sense. I don't have the slides and anything in front of me right now, so yeah, it's
Okay.
just been trying to follow.
Trust me, we tried very hard to not say this and that, but anyway. Yeah, I'll prep a diagram and make sure that everybody is on the same page. So the last thing that I want, or we want, obviously, is to hear, this class is doing this way and the other class is doing the other way. And so this is for everybody to be okay with this, okay? All right, and I lost him too. Okay then,
Yeah, awesome.
what do we need to do?
Okay, are we hung up?
Yeah, we're done.
The piece you missed was about the peer evaluations, because we're going to assign it, they're going to do it, we're going to have the results, and we have to dole out the results for team again on the backside. And Robin was saying, shouldn't we be doing this on Monday, Tuesday, Wednesday next week? And so put us.
Is anyone there?